Hey guys, Brandon Productions here, and today I'm actually going to be making the long-awaited part 2 of how to make a Java platformer game, using the standard Java libraries and no external libraries whatsoever. So essentially everything is going to be hard-coded ourselves, and we are going to attempt to create this game from scratch. But before I actually begin this tutorial, I would like to demonstrate my new channel design. It's very nice. Actually, I love it a lot. It comes with the complete package, a header with some image mapping, a display picture, and this awesome background. It's actually designed by my friend Max, who owns his own YouTube channel called Altus Tech. It's actually a featured channel on my channel, and he does a lot of Photoshop tutorials. So if you want to learn how to make something like this background, you could actually take a look at his channel. But as far as I'm concerned, this is probably the best upgrade that my channel has ever had. So anyways, without further ado, let's get started with our game development. So we open up Eclipse right where we left off, and yes, I am using the standard version of Eclipse. I got a lot of questions in my last tutorial. I am using the standard version of Eclipse, no plugins, no things. I don't know. It's an open source Java editor, so go ahead and download it. The link will be in the description. And so opening up our project where we left off, we actually had a plan going where we have a applet that is actually going to be the level editor, and then we've got an array of objects, and we're going to have these objects as 25 by 25. So there's going to need to be a key listener and stuff like that. But what I didn't really take into account is platforming games are very eccentric. There is a lot of detail that goes into them. So after I made the first video and I started working on my own platformer games, I realized that I kind of started this off on the completely wrong foot. So what I'm going to go ahead and do is actually kind of rework the project without disposing of what we completely have. So what we have here is we have our level editor, and it's an actual applet. But the thing that is, we do not actually want it to be an applet, because that makes loading images and altering the images extremely difficult. Because an applet is actually something that is meant to be run inside the web browser. So it makes loading images, altering them, saving things extremely difficult. So it's just a lot easier if we make this a desktop application. So we're going to go ahead and switch our tutorial from a web-based game over to a desktop-based game. So without further ado, what we're going to do, the first change we're actually going to do is this level editor itself. We're going to switch it from an applet to a canvas. Now what a canvas is it's essentially a blank panel where you can just put everything. It can still do all the things that we wanted to do with the applet, but instead of actually running in the web browser, it's just a blank panel. So the next thing that we're actually going to want to do is, since we've got our canvas here, what we want to do is we actually want to make our own window, our Windows window. Not really Windows window, but the actual application itself where the level editor will be run. So I'm just going to go ahead and right-click our level editor package and press New Class. So we're going to create a new class, and this is going to be our JFrame class. Now, for those of you that do not know, JFrames are actually just essentially this. As you can see here in this new Java class window, there's an X button, a maximize button, and a minimize button. Well, there's no minimize button actually, but there's a close button and a maximize button. And it's running inside of our machine, our Windows machine. Well, I'm running Windows, but that's besides the point. So our JFrames are actually going to be exactly this, these little windows. So what we're going to make now is a new class, and we're just going to call it level editor window. We're going to press finish and wait for it to do whatever it needs to do. So this class is actually going to be the actual JFrame itself. So the first thing we need to do is actually make it a JFrame. So we can do this by extending the JFrame class. So what we're going to do is we're just going to type extends JFrame, and then it's going to want us to import the JFrame class. So we can do that by clicking on this little light bulb here, this error, and it'll automatically import it for us. Okay, so now the first thing we need to do when we actually construct our JFrame is we're going to want to create a constructor. So we're going to say public level editor window. So this is what is going to be run every time a new JFrame or a new level editor is created. And what we actually want to do is we want to set up a parameter that takes in the name of the window, so we can create multiple level editor windows with different names. So, step one, we are going to, when creating all JFrames, the first thing you want to do is actually tell Java what to do when you want the application to close. So what we're going to do is we're going to say this dot set set default close operation. And then we're going to do JFrame dot exit on close. Sorry about that. I'll pause the video real fast. Okay, so it's finally decided to respawn. So we're going to do set default close operation. And then we need to specify an operation and it's an integer. And these are all stored inside the JFrame class itself. So we're going to do JFrame dot exit on close. So this essentially sets it up so when we press the little X in the corner of our window here, it'll actually dispose of all the resources and actually close and exit our application. Now the next thing we want to do is we actually want to set up a size. So we're going to set up a new dimension, which is a built-in class that actually stores size. So dimension window size equal to new dimension. And then we just need to specify a width and height. So we're going to specify, we're going to make this application 800 by 600. The standard Windows 95 resolution. Or Windows 98 resolution, rather. And then what we want to do is we actually want to say this dot set size, and then we're going to say window size. So now what we have is when we run this application, nothing will happen because never mind. We'll just keep on creating our form. Okay, so the next thing we're actually going to want to do is what we did here in the constructor is we're simply setting up what we do when we close it and the size of the window, but we never actually tell it to make the window itself. So what we need to do is actually say super name. So what that does is it calls the constructor of the JFrame class of which we are extending. So what that does is actually sets up the JFrame itself, and it sends in the name that we specify with our parameter. So since this class here is not an applet, what happens when we run it is it essentially runs the public static void main method, which is the code, or which is what executes on all Java applications. And in this main method, the first thing we're going to want to do is we're going to want to create a new level editor window. So we could say level editor window equal to new equals new level editor window, and we're just going to send in the name of level editor. And now what we want to do is we've got this our JFrame here, and what we want to do is we actually want to put our level editor canvas inside of the JFrame. So first we need to actually get the panel to put the canvas inside of. So we're going to say container content pane equals window.getContentPane. So this sends us a panel in which we can put our actual level editor class in. And now what we want to do with this content pane is we're actually going to give it a sort of layout so we can further set things up. So what we're going to do is we're going to use this thing called a grid layout. So we're going to say content pane.set layout, and then we need to actually specify a layout. So we're going to give it a new grid layout, and inside of the grid layouts constructor we actually need to specify how many columns it has and how many rows it has, since it is a grid. Well, we only have one thing to put in it for now, so we're just going to give it one column and one row. So essentially we're creating a box inside of the window panel to put our canvas in. So now the final thing we need to do is we actually need to put in our level editor canvas. So we're going to say level editor edit equals new level editor. And then we're going to say content pane, which is our panel here, dot add. And then we're just going to send an edit. And then finally we're going to say window dot set visible true. So now if we actually run this application here, if it ever decides to run, you'll see that it pops up with this nice window that says level editor. And the size of this window is actually 800 by 600. And this sort of dark grayish area in here that is a result of my my theme that I have installed on my computer. This is our level editor. So that is pretty cool. So now we have our basic window set up, and we just put in our level editor canvas. So let's go ahead and go back to our level editor canvas. Now there are a few things we need to set up. When we actually create the new level editor, the constructor is going to be called. And what we want to do is we actually want to make this level editor canvas the same exact size as the level editor window that it is inside. And what we're going to do in order to do that is we're going to create a new private variable, and it's going to be a private level editor window, and we're going to call it frame. So this is going to be the window in which this canvas is inserted. And then when we create a new level editor, we actually... Oh, wait, no, we could care less about that. I'm sorry, we don't want to do that. So when we actually create a new level editor, what we want to do is we want to specify a size. So we're going to specify dimension size. And it's going to have us import dimension. And then what we want to do with this size is we want to this.set preferred size, and then we're just going to put in size because that is the parameter in which we specified in the constructor. So now that we naturally created a new constructor, we're going to want to go to our level editor window, and we're just going to want to plug in a size. So we can do that by saying window.getSize. And there we go. So now what we have is when we run the application, we have a window and we have a level editor canvas that is actually the same size as the window. So we are all set. We've got our canvas set up, our window set up, and now what we need to do is we need to actually start designing the canvas. So what we're going to do when we actually design this canvas is we are going to use a method called DoubleBuffering. Now DoubleBuffering is actually relatively hard to explain, so I'm just going to draw up this really chintzy paint diagram in order to explain it to you. So what happens in every game is the user has their computer screen, right? And most games at their optimal setting run at a frames per second rate of 60 frames per second, which means every second the screen, which is right here, actually clears itself and then redraws what's on the screen 60 times. Our computers do this by themselves without any games running. So essentially, if we could see fast enough, if our eyes could actually capture light fast enough, we would see the screens in front of us constantly flashing. That is one of the reasons why if you hold a camera up to a computer screen, there is a flashing, because it is constantly refreshing itself. So what we want to do is when we create our game, we want our game to run at 60 frames per second as well. But the only problem with this is if we have one screen, what we do is we draw on the screen. So let's just say this is our game. We have a couple squiggly lines and everything. And we want to draw on the screen, and this is our player here. And we want to draw on the screen at 60 frames per second. So every second, this screen is being cleared and then redrawn on. So while we're moving this character by pressing the arrow keys, the screen is also clearing itself, and at the same time, it's trying to redraw the new image of the player being over here because we're moving him. And as you can see, that is a lot for the computer to do. So essentially what it's trying to do is rapidly move, clear, and draw things on one screen. And as it tries to execute this, it actually, what the user of the game actually experiences is a lot of flashing. So there's going to be a lot of flickering lines all over the screen as they try to do this. So how do we solve this problem with our game? Well, we use a thing called double buffering. So what we do, in a sense, is we have the user screen, which is here, and we have a secondary screen, which we call the back buffer, here. And how all of this works is we have the user screen, so when we start the game, the user actually sees a picture of the player and the scenery and all that, right? And the user screen is still refreshing at 60 frames per second. But in order to actually not make the flashing visible, we set up this thing called a back buffer. So every time the screen actually needs to refresh, it draws the screen's new image onto the back buffer. So let's say the player moved backwards a little bit on this new image. And suppose that's the same tree and those are the same cloud things as on the user screen. So the user actually moved back a little bit in the actual game. So immediately this has no effect on the user's screen whatsoever. But what we do is we actually draw the new image onto this thing called the back buffer. And then once everything is drawn onto the back buffer, we take the back buffer and draw the whole thing onto the user's screen. So essentially what we're doing is we're reducing flashing by making a second monitor that is invisible to the human eye, and we're drawing everything on that, and then all at once we're putting everything on the user's monitor. It's very important to understand this concept as we go throughout this tutorial. So without further ado, we're going to go ahead and set up this back buffering for our actual project. So in order to do this, there are two things that our canvas is actually going to need. It's going to need a graphics, so we're going to say private graphics, and we're going to call this buffer graphics, and we're just going to make a little comment, the graphics for the back buffer. And it's also going to need a strategy called buffer strategy. So now what we need to do is we actually need to import graphics, and I just realized that we're not using strategy, we're using a thing called buffer strategy, at least I think. Yes. So then we're going to import the buffer strategy. So now we have a buffer graphics and a buffer strategy. Now both of these things are going to be used in order to access this back buffer here. So in order to actually set up this back buffer, the first thing we need to do is, well, I'm just going to let you know now, we are going to use the Java's library called strategy. So the first thing we need to do is we need to actually make our canvas here implement a runnable. And what this allows it to do is it allows it to actually constantly run without slowing down anything else. So we're getting into kind of abstract programming here because we want our game to run on its own without messing up anything else whatsoever. And as it implements this runnable here, it's actually going to have us add a method. And this method is called the run method. We're just going to take it and pop it up here. So this run method is actually what we're going to, this is where our whole level editor is going to work. So we're just going to put that comment here. This is what runs when the level editor is running. So the next thing we're going to create is we're actually going to, well, let's just say this. Since we want this to constantly run, we're going to want this method to constantly loop itself. So we can do that by putting down a while statement, and while true, we're just going to run whatever. So this is the program's logic, if you will. Now, in this while method, there are a few things that need to be done. It needs to actually do the logic. So what it's going to do is it's actually going to move everything that's on the screen, so it's going to do all the math and calculations behind the level editor. The next thing it's going to do is it's going to clear the screen, or clear the back buffer rather, and then finally it's going to draw the back buffer to screen. So this is essentially our basic layout of our program. The next thing we actually want to do here is, as we can see in this run method, since we have a while true statement, it's actually going to run in a constant loop, and we do not want our program to constantly be running, because then there's nothing to determine when the program should stop. So up here in our private variable section, we're actually going to create a new boolean, which is a variable that can either be true or false, and we're going to call it running. So while this boolean will actually keep track of whether or not the program is running. So we can just put here while running. So therefore, every time, or the program will constantly loop while this variable is true. So that's basically it for our program's logic. Now, the next thing we need to do is we actually need to set up this strategy so we can clear the errors on this method and get the back buffer actually going. So in all applets, there is what's called a paint method. Oops, paint, not pain. And this paint method is what's called when the applet is actually created. Now, same goes for canvases. When the canvas is actually created, the paint method is called, and this paint method is what actually draws things onto the screen. So what we want to do is, this is pretty much the first method called. So we want to say if buffer graphics, actually, we're going to say if buffer strategy is null, which it should always be, since, well, it should be when this is first called, because we have not set a value for this. We can actually say, just to be sure, that these are both equal to null up in our private variables section. Null. So if the buffer strategy is null, then we actually need to create a buffer strategy. So we're going to say buffer strategy equals this dot create buffer strategy. And then it's going to ask us to send it a parameter called numBuffers. Well, this is actually a number that signifies how many screens we want to use. Well, since we want the user screen and we want the back buffer where we're actually going to draw everything, we're going to do the classic 2. So that is essentially just the classic example. Oh, I'm sorry. So then, since we're creating a buffer strategy, the next thing we want to do is we actually want to set buffer strategy equal to this dot get buffer strategy. So now our global variable buffer strategy is actually saved as the actual buffer strategy. And now the last thing we need to do is we need to set up the buffer graphics. So we're going to say buffer graphics equals buffer strategy dot get draw graphics. So now when the program is actually started in the paint method, we set up the buffer strategy, and yeah, that's pretty much it. So we set up the buffer strategy so we can actually double buffer. And now what we want to do is actually set up the program so it can run on its own. So we're going to create a new global variable, and this global variable is actually going to be called a thread. And we're just going to call the variable called thread. Or we're just going to call the thread. Sorry. So what a thread is in computers, or we can think of this like a blanket or clothes. Clothes are made of several millions even different threads. Now each thread is in fact its own thread. So if you were to alter one thread on your clothes, you would not be altering any other thread. Like, for example, if you have a loose thread and you pull it off your shirt, you're not disrupting the behavior of any other threads. So the same goes with programming. We're creating a new thread that can run on its own and not disrupt the behavior of any other thread. So now what we want to do is we actually want to set up this thread so it actually works and has behavior. So in the init method here, which is what is run when You know what we're actually going to do? We're actually going to go ahead and get rid of this init method here. And we're going to do everything inside of the constructor. So inside of the constructor, we are setting this preferred size, and we are setting this add, or we are adding the key listener. And the next thing we want to do is we actually want to turn this thread into a thread that can run itself. So we're going to say thread, or this.thread equals new thread. And then what it needs is it actually needs a runnable as a parameter. So essentially we could create a new runnable, but as we have here, our program called level editor actually implements a runnable. So we're just going to send in this as a parameter. So now we have a new thread set up, and when the thread runs, it will run this run method here. So when the level editor is actually created, we are also going to set running equal to true, because we want the program to run right off the bat. And then at the end of the paint method here, where it creates the buffer strategies, we're going to want thread, or this.thread.start. So this will actually start the thread and initiate this run method. Whew! Okay, so a lot goes into making a program that automatically refreshes. So there are a few more things we actually need to do. Right here, at the end of this while statement, since we don't want the computer to constantly refresh the screen so fast that we can't even see what it's drawing, before it actually clears the screen and redraws it, we are going to actually make our thread pause itself for 10 milliseconds. So this can be done by first accessing the thread. So we're going to say thread.currentThread, and that allows our program to access the thread in which it is running on. And now we want it to make it wait. So we put this in a try statement to catch any errors that may occur. And we're going to say thread.sleep, and then we're going to send in 10 milliseconds. And then we're going to catch any exceptions that may occur, and we're just going to e.print stack trace. So right before the program refreshes itself again, it's going to wait 10 seconds. Okay, now that is a lot to deal with. So what we're going to do now is we're going to, before we end this video, we're just going to make these three general methods and set them up really quickly. So first of all, we're going to have the public void doLogic. So as I said before, this is where all the calculations of the calculations of the level editor. This is where all the calculations of the level editor are going to be stored and operated. So the next thing we need to do after we do logic is we need to clear the back buffer. So this is actually a complicated process, but it's actually not. So what we're going to want to do is we're going to want to put this whole clearing, so this is going to clear the secondary screen that we can't see. So we are going to want to put this whole operation into a try statement. So first of all, we're going to say graphics G equal to no, we aren't. Yes, we are. We're going to say buffer graphics, which is our global variable keeping track of the second screen graphics, equals buffer strategy dot get draw graphics. Okay, so after we've done that, we're going to make a try statement, and this try statement is actually going to go ahead and clear the back buffer. We're also going to put a catch statement in there, catch exception E, and in this case we're going to need a finally statement. So, whoa, okay, sorry about that, I don't know, I just wanted to check how long we're currently going on the video. This is a 30-minute video, that is not good. We're really running low on time, so I'm going to try to pick up the pace. So to clear the back buffer, what we're actually going to want to do is we're simply going to want to say buffer graphics dot clear rect, and then we're going to say 0, 0. So what it's going to do is it's going to take a rectangle and it's actually just going to draw white over it. So it's going to clear the entire screen, or at least we want it to. So we want it to start at the point 0, 0, and we want it to go to this.getSize.width and this.getSize.height. So there we go. Now we're going. So we've cleared the screen, and if any errors occur while we're trying to clear the screen, we are actually going to print the stack trace. And then once we are done clearing the screen, we want to release some system variables or some program variables, and we're going to buffergraphics.dispose. So this will take the back screen graphics and release them so we are able to use them. Okay. Okay, so when I was actually setting up the program's logic, I messed up a little bit. So we've got the do logic, which is fine. And then what we want to do is, instead of the clear back buffer, we're just going to want to have this method called draw. So what this method will do is it'll actually clear the back buffer, and then it will draw everything to the back buffer. So right here, after we're done clearing the rectangle, this is where everything will be drawn to the back buffer. Okay, and then so once we're done using the back buffer, we're just going to dispose the buffer graphics and allow our program to run more efficiently. So the final thing that we want to do is we actually want to draw the back buffer to the screen so the user can actually see what's going on. So we're going to create the new method, public void draw back buffer to screen. And in this method, this B is going to be lowercase. In this method, there are going to be two things we need to do. The first thing we need to do is actually show the back buffer onto the user screen, and the second thing we need to do is sync everything. And these can be done with two very easy commands. So the first thing we're going to want to do is access the buffer strategy, and we're just going to want to say show. So this will show the buffer strategy or the buffer graphics onto the user's screen. And the second thing we want to do is we actually want to sync everything. So what we're going to do is we're going to say toolkit.getDefaultToolkit.sync. So this will sync up our program's back buffer with the user screen, and it will also sync everything to make sure everything's in check. So there we have it. Now we have the basic logic of the program. And if we run our program, you can actually see that nothing has changed whatsoever. But that is a good thing, because what we are doing is this program is actually constantly refreshing itself, and it's doing so fast that we can't even see it. But so in order to demonstrate that our program actually works, I'm just going to create a quick rectangle. So I'm going to say private rectangle rect, and when we create the level editor, rect is going to become a new rectangle, and it's going to be at the position 0, 0, and it's going to have the dimensions of 25 pixels by 25 pixels. So we're going to import rectangle, and then we can actually test out our methods. So the first thing we want to do in the do logic is we're going to want to set our rectangle. We're going to want to move it over one spot. So essentially the rectangle is going to be moving across the screen. So we're going to say set location. So the x location, we're going to say rect.x++ or +1. And then the y location, we're going to say rect.y. So there we go. We're setting the location of the rectangle. And now what we want to do is in our draw method, we're actually going to want to draw the rectangle to the screen. So we're going to say graphics 2D, and we're going to create a buffer graphics 2D, and it's going to be equal to graphics 2D. So we're just going to convert buffer graphics into a graphics 2D really quickly. So then once we do that, we can say buffer graphics 2D.draw, and then we can just send in rect as a parameter. So it will draw our rectangle to the screen. And if we run the level editor window, you can see that our rectangle is actually moving across the screen, and there's no screen flickering going on, and the movement looks really smooth. So there you have it. We just set up the most painful part of the program, the actual structure, the back buffer, the actual logic behind the program, and the part where we actually can draw stuff to the screen. So thanks a lot for bearing with me during this tutorial. I was going to separate this tutorial into several different parts in order to make it more understandable, but the thing is, I knew I would get too lazy, so I just put it all in one, what has it been, 30 minutes? Yep, one 35-minute video. So thanks a lot for bearing with me, guys. I hope you enjoyed this video. Part 3 should be coming soon, where we actually start designing our new blocks where they can be placed on the screen. So have a fantastic day, guys. Remember to rate, comment, subscribe, and talk to you guys later. Peace.